All right, so let's get started. So the first thing we'll be doing on how these classes will run is we basically have 6 classes together in this course over 2 weeks. And we'll be learning 3 different units. Each unit is going to be comprised of 2 classes. The first class will be the content, and basically everything you'll be learning in that unit will be done in that first class. The second class will be activities like Kahoot and Q&A sessions, practice sessions. Doing all these is more of an interactive time for you guys because I don't want to be the only person talking. And again, this course is supposed to be a teacher effort and a student effort together. So for today, we'll be going over the overview of this course and we'll cover into kinematics. Hopefully we can get the entire kinematics done today. And this Wednesday when I see you, we'll be doing Kahoot and also some Q&A practice sessions. Sorry everyone, I'm not really sure how to stop annotations because this is my first time using this type of Zoom. Okay, never mind, I got it. Okay, so I took AP Physics 1. I just want to talk a little about myself. I took AP Physics 1 last year. And again, because of the coronavirus, the test got changed into 2 free response questions. So my teacher was actually Mr. Miller. And these are the 3 laws, or like the 3 things that he told us were really important when taking the AP Physics 1 course. The first one is don't forget your units. And units are very important because if you have never heard of, but like the Boeing 747 or one of the aircrafts made by Boeing, they basically crashed because one of the people coding behind the coding of the aircraft used a wrong unit conversion. And so basically if you have like 10 pounds, he probably put like 10 ounces, which is a significant difference. The second law is when in doubt, draw a diagram. You know, sometimes it's good to just draw a picture and, you know, just put it out there on the paper and think it through. The third most important law is it's not about the numbers, it's more about the relationships. In physics, a lot of people, they take the calculator and they jam numbers in them to get values out, but it's more about thinking the concepts and what's behind this and how can that help you. So try now, just put like if you have a calculator next to you, try putting that away and just, you know, get into this mindset of you thinking about relationships rather than numbers. All right, so what is kinematics? Well, according to the College Board website, it is the study of motion. And the study of motion is basically position, velocity, and acceleration, and also representations of motion. It's fine if you guys don't understand what these terms are, I'll be explaining it later. So again, when you guys took this class, I asked you on ED and also on the website about my course, about this question, and I was asking all of you to answer this question and be prepared to answer this question. So if any of you guys would like to explain your answer choices, you can either put it in the chat or just raise your hand and I'll unmute you. I see a lot of people putting C. Let's go with Jake Chen.
Hi. So, I think I once said it in the reasoning yesterday as well in the thread. It's basically there isn't really an atmosphere around the moon. So there, like everyone said, there's really not much air resistance to kind of push the feather up as the brick falls down. So theoretically, they will all fall at the same time and at the same rate.
Yeah, that's a wonderful answer. Um, Zakia, would you like to talk about it? Okay. Um, Lily S-J.
Okay, so I would also choose C because of what Jake Chen said. There's no resistance to air pressure because when you're so let's say that you weigh like 90 pounds here, like 93 pounds here, and you go to the moon and you weigh 1/6 less because 1/6 of that of your regular weight on Earth because there's no air resistance or gravity. There's a lot less gravity pushing you down and no air resistance. So that's why both of the and it's the same concept with these with this.
Okay, so thank you, Lily. Most of your answers are correct. The answer is C. And the reason being is, as you guys said, it is because of air resistance. And on the moon, there is no atmosphere. So there is no really any medium between the objects and the surface. And therefore, you don't have any air resistance. And both objects fall at the same speed. Just for clarification, I saw one of you guys put in the chat that there's no weight. That is not really true on Mars, on the moon, because every planet has a gravitational field strength. It just depends how strong it is. That's why if you're an astronaut on the moon, you could be jumping up, but it'll take you 10 seconds to come back down, compared to if you're jumping on the Earth and you just come back right down really quick. Um, Weight does change, and that depends on the gravitational field strength, which I will be talking later. Um, but the mass remains constant. So there is a confusion between mass and weight. Your mass is kind of like the amount of matter you have. It's like a measurement that is unique to you and that object only. But weight changes depending on where you are. So just get that in your um, just get that in your head if you have that confusion between mass and weight. Mass always remains the same. It's like a identity, like a passport only for you. It's amount of matter. It measures the amount of matter you have, and weight changes depending on where you are. So Derek, you have a question. Mass is how much it weighs on Mars, on Earth, right? So mass is it's like a measurement of how much matter you have. It's not really how much you weigh, because you could weigh differently on different parts of the Earth. It just depends. But I'll be covering that later. So it would be really nice if you guys could just hold your questions and have it at the end of the session. That way I can have more time to answer them and get through this really quickly. All right, so the beginning of kinematics starts with vectors and scalars. So vectors are kind of like, you could think of them as something that has a measurement and a direction. So let's just take driving a car for an instance, right? Let's say you're driving a car in a straight road, on a straight road, right? So you have a speed, right? Your car can tell you you're driving right now at 25 miles per hour, but then there's also an acceleration, right? When you press the gas pedal, you accelerate, so that means your speed is changing, and you also have a speed. So the difference between speed, velocity, and acceleration is that speed is a scalar. So scalars are objects that don't have direction; they only have magnitude, and magnitude is just a term to it's just a term to describe like a amount of something. So let's say if I have like 60 pounds of bread or something, like Italian bread or something, that's a magnitude. But if I say, oh, I have 60 um 60 pounds of bread at this location, that's kind of like telling you the amount and the direction. So that's kind of like a vector. So if I told you I have like $25 right here, right? That's a magnitude, that's a scalar. But if I tell you where that $25 is, that's going to be, that's a vector. All right, so after that analogy, let's talk more about physics terms. So what you need to know for AP Physics 1 is mostly speed, velocity, and acceleration for the beginning. The diagram on the left, the NASA diagram, there's different terms, but those terms will be discussed later in this course. And some of them might not be discussed because this course is only covering 3 units. But again, speed is a scalar and it's in magnitude. So it tells you like, if you're driving a car at 25 miles per hour, that is your speed. But if the car tells you you're driving 25 miles per hour at 3 degrees with respect to a horizon or a reference line, that's a velocity. Okay, and velocity is really just like speed, except it tells you the direction of that speed. Okay, so acceleration. Acceleration is a vector because it tells you the direction and magnitude. So as I said before, let's say you have a car driving at 25 miles per hour, right? And you have, let's just say you include air resistance. So that air resistance is kind of like it's a force, right? It's pushing you back. It's pushing that car back. And it's providing that acceleration in the negative direction, right? So that is a vector. It tells you, okay, this air resistance is acting against your car, and that force is going the negative direction, which is creating that acceleration in the negative direction, right? So acceleration, the difference between vectors and scalars is really important because if you don't specify your direction, things can get very complicated and you get very wrong results. Are there any questions? Speed, velocity, acceleration? You can always type them in the chat if you like to. All right, so I'm gonna move on to displacement and distance. So distance is kind of like it's scalar, and displacement is a vector. So displacement is like, let's say you walked 5 miles to this store, right? You're walking 5 miles north, right, to reach this store. But then after you reached that store, you came back home and you walked that 5 miles back. So your total displacement is actually 0, because displacement basically measures your distance between your starting point and your ending point, right? And that displacement basically tells you like, this is the distance you've traveled. This is the amount of distance you traveled from your beginning to your ending point. And so displacement is like your final minus your initial point, and that tells you the displacement. For distance, let's say I walked 5 miles north, right? And I came back 5 miles, your distance would be 10 miles because you walked 5 miles up and you came 5 miles down. And that's a scalar because it doesn't tell you any direction. And sometimes it's very important. That's why we divide in physics, we divide quantities between scalars and vectors, because different quantities can be used for different measurements, and it is important to specify which one is which. Okay, so next page. Okay, so after we learned about vector additions and scalars, we do something in physics called vector additions and components. So as I said before, vectors are basically scalars with direction, right? They tell you the amount of something and they also tell you the direction. So as I said before, right, you have a car driving at 5 miles per hour at, let's say, 30 degrees with respect to the x direction axis, the horizontal axis, right? That vector has an x direction and has an x component and a y component. So basically what you would do is, I don't know if most of you have learned trigonometry yet, but basically SOHCAHTOA is basically a measurement for sine, cosine, and tangent. They're just measurements in trigonometry. They're like ratios. So so let's say you have a triangle, right? Let me just draw in here to make it more easy for you guys to understand. So you have a triangle, right? And let's say you're driving your car this is the arrow that represents the direction of the car at 30 degrees, right? And that's with respect to this horizon. It's like a reference line, right? It tells you the angle and direction of your vector. And so if you have a car driving at 30 miles per hour, right? You basically have an x component and a y component. And in trigonometry, we have something called sine, cosine, and tangent. This might seem really confusing to you, but think of it as basically like ratios. Like I have a 2-to-1 ratio or 3-to-1 ratio. They're just measurements in math, okay? So sine in trigonometry is basically your opposite side over your hypotenuse. And your hypotenuse is basically your longest side. So this is your hypotenuse, this is your opposite side, and this is your adjacent side with respect to this angle. Okay? And then your cosine is basically your adjacent over your hypotenuse. And then your tangent is your opposite over your adjacent. These are just ratios. I can't go really in deep in it because, again, I'll be teaching trigonometry and not really AP physics, but this is a ratio that you just have to remember in your head for now. Okay, so when we do something called vector addition, it's basically adding like the x component with the x component and the y component with a y component. So right now I have 30 miles per hour, right? And to find the x component, what I would do is I would say cosine 30 equals your adjacent over your hypotenuse, which is really your x over your hypotenuse. And that hypotenuse is represented by 30 miles per hour, okay? So you would basically have 30 on the bottom and you would have x on the top. So to find x, what you would do is you do cosine 30 times 30 because that will tell you the x component. And for the y component, it's the same thing except you use sine. So you would have sine 30 equals y over 30 miles per hour. And to find y, you just cross multiply and you do sine 30 times 30 miles per hour. Okay? You got it? You guys got it so far? Do you have to repeat anything else? Yeah, I'm sorry if you guys are not in high school and you're in middle school. This course is more designed towards high school students, but it is fine if you're a middle school student. It's always good to challenge yourself early in the stage. But definitely I'm focusing more on the conceptual side, but there are some mathematics that I have to get through before reaching into like the middle of the course. There are some like basic mathematics that you need to know, but it's definitely good to stay tuned and basically just listen throughout the way. Okay, so after I got cosine and sine, right? You could also use tangent, but the thing about tangent is it always depends on what you state your angle as. So right now I'm stating my angle as 30 degrees, but that 30 degrees is not like here, it's right here, right? So it always depends where you state your angle, and that's why it's very important that whenever you do physics calculations, you always specify everything. So if I were to say it right here, I would say 30 degrees with respect to the x-axis. Okay, so why do we need to learn about vector additions? So the thing about vector additions is, let's say, right, I have this car driving at 30 miles per hour, as I said before, with 30 degrees with respect to the x-axis. And then later, I stop the car and then I start driving the car at 40 miles per hour. But I do this at an angle of 90 degrees, right? I make a right turn and then I start driving at 40 miles per hour. So if you want to find your velocity, right? As I said before, velocity is a vector. Your velocity, what you would do is you would basically take, let me just draw in a different color. So you would basically take your x component of your first vector, which was 30 miles per hour at 30 degrees. Then you add that with the x component here for your 40 miles per hour. That would give you your total x component. Okay? After you find your total x, you then find your y. So you basically take the y component of your first 30 miles per hour vector, you add that with the y component of your second vector, which is basically 0, because it's 90 degrees. It's not going up or down. It's just going horizontally right. So after you find your total x and your total y, you would basically use something called Pythagorean's theorem, which you might have learned in geometry before. And that's basically saying a squared plus b squared is equal to c squared. Okay? And you would take your x would be your a, your y would be your b, and you would basically plug that into the equation and square root everything to find your final velocity. And that would be your vector, your final your vector. Okay, so if you I understand my handwriting is probably really messy for you guys, but if you look at the diagrams as well, they also show you what I'm basically talking about, except they don't have like a lot of math. It's just really simple. Does anyone have any questions before I move on? Okay, so let's say you have difficulties with math, right? You don't really understand what I'm talking about. But basically, if you think of vector additions, it's basically you're taking apart a vector, because as I said before, vectors have magnitudes and direction. They tell you the angle, and they also tell you the amount of that object that you're talking about, right? You could think about vector additions as taking apart that vector with the direction. You break it up into x and y components. And so if you have 7 vectors, right, you just take the x directions of all 7, you add them together, you find your total x component, right? And then you take the y components of all 7, you add them all together. Then you make one final triangle, which is right here. Which is right here. Yeah. So I just circled it. And you use Pythagorean's theorem to find your final c value, which is basically your vector, your final vector. It'll be like a vector sum. All right, so I'm just going to clear this for now. And I'll move on to the second page. Okay, so now there's something called projectile motion. I think most of you should have heard of it. It's like playing baseball. When someone throws a ball at you, right? You hit it, and you try to estimate how far it goes, right? Projectile motion is very similar to what I just said before, except it's in 2 dimensions. So now you have something in the x direction and you have something in the y direction. So it's basically like vectors, like adding vectors. The thing about projectile motion is that it's a little more complex, and you need to understand some algebra to understand this. So I'm gonna first start off with the diagram to the left, right? You have a projectile, right? It's launching upwards, and at an angle, right? It tells you the initial velocity with respect to some angle, theta, right here. And they tell you it's going up, and its apex, its highest point is point B, and then after point B, it comes back down to point C, which it started, the height which it started at. So in AP Physics 1, we don't deal with air resistance because air resistance is very complex. I have done a little before, but it involves calculus, and that's something you would learn. you would learn in calculus and physics C, AP Physics C. But in AP Physics 1, we don't deal with wind resistance or air resistance. Okay, so now I'll be moving over the x directions and the y directions. So basically in physics, right, whenever you have something with a vector, we always break it up into x and y directions. That's kind of like a reference or a coordinate system that we use to, it's like a universal language that we can all understand. So in the x direction, which is basically this way, and the y is this way, the velocity is always 0 because there is no air resistance, and so their objects is actually moving in the x direction at the same rate. So your velocity is always constant. It's never changing. However, your acceleration, okay, so before, I don't think I covered this, I'm sorry, but acceleration basically is the change of velocity over time, right? Velocity is equal to change in distance over time, like 30 miles per hour. The miles is your x distance and your hours is your time, right? Miles per hour, right? And then your acceleration is equal to your change in velocity over time. So, so before I said, like, if you press the gas pedal on your car and you accelerate, right? When I say accelerate, you're basically changing your velocity, okay? And in the x direction for projectiles, your acceleration is always 0. So therefore, if your acceleration is 0, your velocity is not changing, right? So it's constant. For the y direction, you do have an acceleration, and I would like to give you guys a chance to start talking, and not always me talking, because it can be very boring this way. But if you would like, you can type in the chat, what do you think the acceleration is in the y direction? And just to clarify, to have an acceleration, you need to have a force. So what force do you think is acting on a baseball ball? A baseball in the projectile trajectory, like when it's moving. Okay, I got one question. I got one response. Gravity. Acceleration due to gravity. I like that. 9.8 meters per second squared. Okay. Yeah, let me just unmute you guys. Yeah, if you would like to talk, you can just raise your hand as well.
Is it at the apex? Or just in total?
Sorry, what did you say?
You're asking for which point in the graph? Or is it all of the graph?
All of the points, but in the y direction, not in the x direction. So I can be talking about this over here, over here, over here, or over here, but I'm only talking about in the y direction.
That's gravity.
Okay. What else? Anyone else? Okay, so a lot of you guys are saying gravity, right? And you are right. So in the y direction, right, we have gravity because gravity is always pointing where? It's pointing down. And when I mean
to
down,
the center of the earth.
Yeah, it's also pointing towards the center of the earth, okay? But basically in the y direction, you have that acceleration downwards. But in the x direction, you don't have acceleration. It's not like you're attaching like rocket fuel to your baseball bat, no, your baseball and just like launching into space, right? We're not doing that. Okay, so you have an acceleration, and that acceleration is actually g. So what do you guys think what g is? What do you think g represents? It's a variable.
I heard something about it's like G-force, I think.
Yeah, but okay, you guys. Let me give you a hint. You guys typed it in the chat. The answer
Gravity?
is in the chat. Be more specific. Okay, I like it. Gravitational constant. So something that a lot of people say, they're like, oh, what is G? And they're like, oh, it's gravity, right? And then I say, what do you mean by gravity? And they can't
gravitational
specify.
field.
Yeah, it is the gravitational field. And it's not really just a gravitational field, it's the gravitational field strength. And what I mean by gravitational field strength is what I referred to before. Like on the moon has a smaller gravitational field strength. And that's why when you drop a feather, no, not when you drop a feather, but when you jump up, it takes longer for you to come down because it's weaker. It has a weaker field. But on the Earth, you have a stronger field, right? And basically what scientists would do is they would measure the gravitational field strength around the entire planet. They would take the average of that, which would give you 9.81 meters per second squared. And a lot of you guys are saying like 9.81 meters per second squared, but do you know where the meters per second squared comes from?
Meters per second times meters per second. Or the meters it travels for every second that happens.
Not really. Think about this diagram, Adrian. I mean the equations, right? I said velocity is the change in distance over time, right? So in physics, we use something called meters per second, basically saying if I have a velocity of 9 meters per second, I'm traveling a distance of 9 meters per second. So every second that passes, I'm traveling another 9 meters. So in 2 seconds, I'll be traveling 8 meters, right? But acceleration is velocity over time, right? And in physics, we usually use the unit seconds. So you basically have meters per second, right? That's equal to your change in velocity. I'm just talking about units, just units right now, right? And that's change of velocity over time. And time is seconds. So what you would do is meters per second divided by seconds, which you probably have learned this before, but it's keep, change, flip. So you keep the first factor, you change it to multiplication, and you inverse that seconds into 1 over, you take the reciprocal. So it becomes 1 over seconds. So what happens is you get your numerator times your numerator, that's m times 1, that's m. And you get your bottom, your denominator, which is seconds times seconds, and that gives you your second squared. So a lot of people, they kind of get confused between meters per second squared, like where does it come from? But that's basically where it comes from. It's changed in velocity over time. All right. Okay, I kind of got sidetracked with that, but let's continue. So in the y direction, right, we have our acceleration due to gravity, and that acceleration is the gravitational field strength of the Earth, right? And that's 9.81 meters per second squared. Okay, you should know this number and memorize it for your own, to help you in the future in physics. Okay, so our velocity is changing by 9.81 meters per second squared, right? But remember we said that acceleration is a vector, right? So it has to have a direction. So do you guys think that 9.81 meters per second squared is plus or minus? Wait, I'm just gonna write this. This is plus and this direction is minus.
Plus then minus? So it goes up and then flat lines and then goes down?
But you said before acceleration is always pointing towards the center, and for us is pointing downwards. So what direction do you think that will be?
But isn't it going up at the beginning?
It is going up, but I'm talking about the acceleration. I'm not talking about its velocity.
So it'd be going down all the time?
It's not going down. So see, when you talk about objects when they're moving up or down, right? Okay, so let me just give you an example, right? I have a car, right? And it's got wheels, right? It's moving at a velocity of 5 meters per second squared, right? Well, I mean 5 meters per second. However, the air resistance is pushing it back with an acceleration of 3 meters per second squared, minus, because it's opposite to the direction of motion, right? Your car is still moving, however, it's slowing down, right? You're not saying your car is moving backwards because it has deceleration of -3 meters per second squared, but it's still moving, it's just slowing down. So it's the same thing with projectiles. Your projectile can be moving up, however, it's climbing at a slower rate, right? It goes up really fast, but then it climbs at a slower rate. And that's why at the apex, the velocity in the y direction is equal to 0. Because at that point, your acceleration that change due to acceleration made your velocity 0. So you start off with 10 meters per second squared, but after like 1 second, it becomes 0.
So it's always negative. It's always pointing down. But then when you throw something up, it's basically counteracting that negative force. But then there reaches a point where that force that you threw it with can't fight against the force of gravity anymore, so it goes back down.
Okay, so let me just clarify something between velocity and acceleration. Okay, velocity it's like a vector, as I said before. It's telling you what this object is doing, right? It's moving forward at 5 meters per second at this angle, at this direction. It's telling you that, right? But your acceleration is basically your change in velocity. So your object can be going upwards, but that acceleration is in a negative direction. You still have a velocity. Your velocity is still positive, but your acceleration is negative. So you could think of it as
because there's a greater negative force than there's a positive force, so it's always going to be negative.
No, don't think about forces right now because I haven't talked about it. Think more about kinematics, like velocity and acceleration. Don't think about forces yet because it's going to confuse you, and I don't want to give you guys so much at one time because it's definitely you're not going to be able to hold it or like learn anything. It's just going to go through your head and just pop out. But just think about acceleration and velocity, right? Actually, if I can, let me just, yeah, Zakia's right. It's just that acceleration will tell you how fast velocity is changing, right?
Oh, that makes sense.
Yeah. Let me see if I can draw. Okay, so basically you have a ball, right? It's going upwards at 5 meters per second. And this is the x-axis, and this angle is 60 degrees, right? And then it goes up here, and then it has a y direction. It has a y velocity. Wait, actually, sorry. It has a y velocity in the positive direction because it's still moving up, and it also has a x velocity, right? So when I talked about vector additions and vector components, right, I told you guys to break it up into x and y components, right, using sine and cosine. And that would tell you your x component and your y component. But basically what gravity is doing is at its highest point, you have a, you have a velocity only in the x direction. You don't have a velocity in the y direction. Because at that point, in that instant, at that very instant, the ball is not going upwards, nor is it coming downwards, because it's at its highest peak. It's like if you kick the ball up
it's
into
like
the
equilibrium, basically.
Yeah, in the y direction. It's not in the x direction though.
No, because there's no gravity in the x direction.
Yeah, but then once your ball comes down, you would have a velocity downwards, and you would still have that x velocity there. And as you come down more, you get a larger velocity, but your x still keeps the same. And that's why objects, when you drop it super high, they start traveling faster when you come down. It's like they're accelerating.
But then they stop accelerating at some point, right?
That's when they reach the end of the ground. When they hit the ground.
No, there's like, when you fall, like, for example, if you're like skydiving, there reaches a point when you're not accelerating.
Yeah, that's called terminal velocity, but this is something that's not in AP Physics, and I'm trying to get the basics done first. So okay. That is something that's not part of kinematics, but if you're welcome to search it online, it's called terminal velocity. And yeah, basically what air resistance does is it basically reaches a point where it makes your acceleration 0. Like as I said before, when your acceleration is 0, your velocity is the same. and that is your terminal velocity. So this is just a quick diagram of how a projectile would look like. Basically, your x direction, your x component of your velocity would always be constant. It's never moving in AP Physics 1. I'm saying in AP Physics 1. And then in the y direction, you have a velocity initially upwards, but because of acceleration, and we know that acceleration is equal to change in velocity over time, right? If your time increases, then that means that your change in velocity is also increasing because your acceleration is constant, right? Gravity is pulling us down at the same rate. We're not saying like, oh, gravity changes from 9.81 meters per second to 3.81 meters per second squared. It's constant, it's uniform. So we know that this is uniform. So because time is increasing, right, because of fractions, when your denominator increases and your acceleration is constant, your acceleration is constant, you want to keep that equation true. So the only thing you can do is increase your velocity as well, because your acceleration is constant. You guys get what I'm
So
saying?
what would you call so when the ball is going up, is acceleration positive or negative?
The acceleration is negative
Why?
because gravity is always pulling us down at negative 9.81 meters per second squared. That's not going to change, right? It's only going to change unless, let's say, you go on the moon or you go on a different planet. But on the Earth, it's always negative 9.81 meters per second squared, right? There are some limitations. There are some like special parameters that can change your acceleration, but those are things that we won't consider in AP Physics 1, okay? So we know that the acceleration due to gravity is constant, right? And we know that acceleration is equal to velocity over time, is change in velocity over time. And basically, as your ball is going into the air, time is increasing, right? So because time is increasing, the only way to keep this relationship true, to make a constant, you have to increase your velocity. You get what I'm saying?
But then that means it would just keep going up.
Yeah, I understand what you're saying. But because acceleration is negative and time is increasing, your velocity is actually getting more negative because negative divided by positive is negative.
Oh, okay, that makes sense.
Yeah. So that's why we have to really get like
So when
vectors and
when the
scalars.
ball is going down, it's positive.
Yeah. Wait, what? So you said when your ball goes down, your velocity is positive?
No, acceleration. Or is it always negative?
Okay, so your acceleration due to gravity is always negative.
Oh, okay,
But
that makes sense.
it depends like what you state as your parameters, because some physicists, they probably say like, oh, this is positive direction, this is negative direction. But then other people, they say that, oh, this is the negative direction, this is the positive direction. It depends on how
Yeah,
you
that's
solve
what
the
I'm
problem.
confused about.
Yeah, so physics is very flexible, but I'm just trying to get this basic like acceleration, velocity, these things into your brain so it gets stuck there. And then in the future, like when you make your own calculations, you can change that depending on how you want to solve the problem.
Okay, that makes sense.
Okay, and also, if you have questions later, you can always stay on. I will always be the last to leave, but I just need to get through my slides so everyone has an equal chance of learning everything. All right, so okay, so before when I talked about kinematics, I talked about representations of motion, right? And in the college, in the AP Physics 1 course, the representations of motion that they're talking about is really like graphs and diagrams. And graphs are a really important part of kinematics because they describe a lot of things and you can use a lot of things about graphs to help you in your calculations, okay? So let's just go over position versus time graph. So let's just say, right, before I talked about this car and right, this car is going at 5 meters per second, right? Its velocity is equal to 5 meters per second, and its acceleration is equal to 0 meters per second squared. So this would be a graph that would represent this object's motion. So we see that your velocity is constant, right? Wait, actually, I'm sorry. Let me change this really quick. So you would actually have acceleration, but that acceleration is constant. And just make that 3 meters per second squared, right? So on your graph, let's start off with acceleration versus time. Right here, over here. Let's just make this equal to 3 meters per second squared. So it's like acceleration is constant, right? And we know that acceleration is equal to change in velocity over time, right? And so to keep this constant, to keep the acceleration equal to 3 meters per second squared, since it's constant and our time is increasing, we have to increase our velocity as well, right? Because that's what acceleration does. It changes your velocity. And because your acceleration is positive, it means it's increasing your velocity. It's actually not decreasing your velocity. And that's why if you look on this graph, the velocity versus time graph, your velocity versus time graph is actually a straight line. And it has a positive slope. And that is a linear relationship. It means that it's changing at a slope. It has a constant slope. And we know that slope is rise over run, right? So its rise is its velocity, and its run, which is the x, is your time. And v over t is acceleration. So we're fine with that. So for the position versus time graph, it would actually be a squared relationship, because right, your graph is curving upwards, and basically what you're saying is, because your object is accelerating, right, your car is accelerating, it's traveling a greater distance per unit time. So like every second that increases, your car is accelerating at 3 meters per second squared, which means that your velocity is increasing by 3 meters per second each second. So your car is traveling faster and faster and faster, and that's why the position is also increasing as a curve, like a exponential relationship.
What does y mean in this graph? Is it like time?
Okay, so y is a
Or
unit
velocity.
for displacement or
Okay.
distance, and it's used in the y direction. So like before I
Okay.
talked about x and y direction, this is the y that I'm talking about, or the y axis, or that direction.
Okay.
Right, so moving on, let me just go to the next slide. Okay, so there's another part in kinematics called center of mass, and it's basically talking about the point at which it's kind of like the distribution of mass. So let's say if you have like a potato, right, and it has more like matter, right? It's like it has more mass in the left side, right? So this is like all its mass, right? And this is the right side, and let's just say the right side got cut off because someone was trying to make French fries, and so now you got this half of the potato, and this half is gone. Okay, so your original in your potato, your center of mass should be in the center, because plants don't grow like one section greater than the other section, right? It's uniform. But once you cut that section into a half, you're just left with this section. And so your center of mass actually shifts to the right, because some of your mass got divided from the left side. So think of this in physics terms as well. So in physics, we have something called a system. It's a term that expresses more than one object together. So I can have like a ball earth system. I can have a rocket ship car system. It's like a system is comprising more of one object, okay? and a object is just a one individual matter, like a point that you're talking about. So in physics, when you make calculations, you always specify whether you're using a object approach or a system approach, and that also matters when you make your calculations. Okay, so for center of mass, we usually use this in a system approach because for a object approach, it's usually in the center, and we don't really have to make a calculation for that. But when we're doing systems, like let's say I have a car, right, with another car, and this car is slightly bigger, there is a distance between them, right? And that we just call x, and you have a different mass. You have a small m and you have a big M, right? And we want to find the center of mass, or the position at which the mass distribution of both objects is the same with relation to distance. Okay? So how we do that is we basically make a reference line. So let's just make this a starting point line. And we would take the distance from this line to this line, its point, right? Its center point. And we take that distance from this point. And we basically use this equation as follows. We take the m1x1 plus m2x2 divided by the sum of their masses. So let's say you have a system with like four objects or 5 objects. You would do the same thing. You would do m1 x1 plus m2 x2 plus m3 x3, and you just go on forever until the number of systems you have. And you divide that by the total mass of your system. Okay, that's really important. I think when I took the AP Physics 1 test, I don't think there was a question that was about center of mass, but one of the practice questions I had did have a center of mass question, and they were really confusing as well. So you guys can unmute after I'm done talking. I think I can get this done in like 3 minutes, but I'm just trying to get through everything so everyone has a chance and we're not leaving really late. Okay, so that's about it for my slides today. I understand it was kind of very intense for you guys because for me, when I learned kinematics, my teacher gave me like 2 weeks to 3 weeks, but for you guys to learn it in like an hour is definitely a very hard task. And for Kahoot, I said before, our classes will be divided into 2 sessions. The first class will be about the content, and the second class will be more fun. It will be like Kahoot and like practice questions and more of like a Q&A session. So it will be more of like a student thing more than a teacher thing. If you guys really like Kahoot, I can add more Kahoots to my next slides and have them in my first class as well if you would really like that. But for now, because the time is so limited, I have to get through everything and basically push everything into one presentation. But definitely, if you guys want Kahoot, I can add it into my next slides as well. Okay, so practice problems. I posted some on EDX, right? I made 3 different links, and one of them was for my own. It was a practice set that my teacher gave me, and they were actually college level questions. They weren't AP Physics style questions. So you can definitely try those out. I also posted one, I believe called from the College Board site. They also have questions there, but you also have to look through them because some of them aren't just for kinematics. They also have like momentum and stuff like that. And so I also posted one, I believe it's a 1D kinematic review. That's also very helpful if you guys want to think. If you guys want to practice on those are fine. And I also posted study guides, I believe. Yeah, a study guide. And also, if you have questions, you can always text them on ED. And also, I would highly suggest you guys to keep on coming back to these classes. I understand it's really hard for you guys to learn all of this in like such a short period of time, but I would definitely say it pays off at the end because at the end, it's really you guys learning it. It's not really me because I already gone through this process, but definitely try to come back, and if there's a lot of people that keep on coming back, I might make a continuation of this course to cover all the courses. All the units. And also, personally, I think that AB Physics 1 is hardest in its rotation unit. So this is actually like probably the easier parts of AP Physics 1. The harder parts are more of like the rotational parts. But I feel like if you guys get the bottom, like the foundation done, you're really solid set on these foundations, it'll be really easy for you guys for rotation. All right, so now I'm gonna open this time for your Q&As. If you guys have any questions, you can talk in the chat, and then I'll unmute if you raise your hand.
I just forgot my question. Sorry.
Oh yeah, it's fine. Ashley Jin, will you ever talk about the Science Olympiad? Did you come from Francis Lewis? Because I'm not really sure. If you did come from Francis Lewis, yes, we are having a. You can check our website as well, and you should have. There's also a Google form that I can fill out for Science Olympiad, but I'll definitely talk more about physics in this class. Though. Sorry, Lily SJ. I didn't see your question before. Let me just read it real quick. Yes, you are right. Using the equations, I haven't discussed the equations yet because the kinematic derivations are very scary. They do involve a lot of algebra, but definitely look into those. If you guys didn't have the time to, if you guys want, I can also do a kinematic derivation next class about like where you get these equations from. But yeah, you basically got that question right. Yeah. Are there any other questions? Jake Chen, do you have a question?
Can you
Sorry.
put trig practice on the ed page so we can I haven't practiced trig in a long time.
Yeah.
The last time I did it was when I was in 5th grade.
Yeah,
So
you could definitely learn this. I mean, I'll try to find one, but you could definitely just search it up, sine, cosine, trig. Like, I feel like the only trig you would need is sine, cosine, tangent. You're not really going to need any other trig equations, like law of cosine. You're not really going to need that for this course. But if you would like to, yeah, I would definitely add it on.
okay, thank you.
Yeah.
Bye.
All right, bye. Jake Chen, do you have a question?
No, I do not. Thank you for everything.
Yeah, okay. Anyone else have questions? Okay, so Rishi, displacement is relative to both axes because you can have a x component of your displacement and a y component of your displacement because you do have angles that tell you displacement because displacement is a vector. So you do have, it is relative to both axes. How do you find where a projectile lands relative to the base of a cliff? So, okay, so sorry, I didn't have enough time to cover this, but basically in projectile motion, you have horizontally launched projectiles, and you also have projectiles launched at an angle. So if you're talking about horizontally launched projectiles, your angle would be 0. So basically what you would do is you would use a kinematic equation, which I'll talk more about next class, and you find the time it takes for that object to fall down. and using that time, you would take that time and multiply it by the horizontal velocity of that object, because as I said before, in projectile motion in AP Physics 1, the horizontal component of velocity is always constant. So you would just take that time and times it by the horizontal component, horizontal velocity, and that will give you the range. For projectiles launched at an angle, you would have to do more of a vector sum calculation. So you would have to find the time it takes for that object to reach its highest peak, then to come back down to its height that started, which you just find the time and times it by 2. But let's say you have like a cliff, right? So it's going up and it's coming down, and then it has to come down below the cliff. Then you would have to do another calculation for the velocity, the time it takes from the time it gets to the second height to the bottom of that cliff. So it would be a more complex calculation. But I would definitely post like practice questions. Definitely try out those practice questions. It will help you a lot. And afterwards, I would definitely talk about like the other calculations as well. Yeah, Zakia, if you would like, I can actually show you how to do a actual problem. Like I can actually do a problem, but are you like fine with staying like 15 minutes after this? Sorry, I had to like rush everything before because a lot of people have to leave at 3 o'clock, but I would definitely like to go more in detail. Yeah, if any of you guys want to stay, it's fine. It's fine to me. These slides, yeah, at the end of the second class, or probably at the end of my entire course, I will post all the slides. Okay, so center of mass is like, as I said before, it's like a measurement. It's like a point of where all of your mass is concentrated on, right? So let's say I have a water bottle right here, right? It's half filled, but because it's half filled, my center of mass would actually be like near the bottom of the water bottle, because all the top is air, and that mass is like basically negligible. So it's kind of like talking about also like the potato example I gave. Let's say you had a full potato, right? Your center of mass would be in the middle. Once you cut that potato in half, right, your center of mass shifts towards the section that was not cut off. So let's say you cut off the right section, it would shift to the left section because all your mass is now concentrated on your left. And center of mass is not a very key concept that you have to learn about. It's just, you just need to know that formula and understand where it comes from. Okay, velocity increases with respect to acceleration. So if your acceleration is 0, your velocity will never change. But if your acceleration is a value, then your velocity is going to change by that value every second. And that's where you get that meters per second squared comes from. Yeah, Rishi, velocity is like speed, and it is speed increasing, but it also has direction. AP Physics 1 will not cover relative velocities, but probably AP Physics C, I would say. AP Physics 1, I would say definitely harder than AP Physics C. Like the amount of people who get 5s is probably like, I think it's 8.7 this year, 8.7%. People who get 5s in AP Physics C is like 20 or 30%. All right, so if there are no more questions, I'm guessing all of you guys are trying to stay for the projectile motion problem. Let me just see if I can take one. Okay, so just share my screen. Okay, so you have a cliff, right? Oh my goodness, this is such a bad cliff. You have a cliff, right? And let's just say this height is 30 meters. And we have this cannon. It's shooting a projectile out, right? and this angle is 60 degrees. So you have a projectile, right? This is your projectile, and we know that in the x direction, your velocity is always constant. So what you would do to find the time it takes or the range, either or, you would basically use the sorry. You would basically use this equation Vf equals V naught plus AT. Wait, actually, let me just write everything out. Vf squared equals V naught squared plus 2A delta x V delta x is equal to V naught t plus So these are like the three kinematic equations. I didn't have the time to derive them, but they are here. So, and basically the rest of the kinematic equations come from these three basic ones. You just play around with the variables and you just like isolate one variable to find, and then you get a new kinematic equation. But these are the basic ones. So we first find the x velocity, right? So we do like a vector addition calculation. So this is your y, this is your x, and this is 60 degrees. And let's say this object is being launched out at 30 meters per second. Okay, so what you would do is you have a 30 meters per second velocity, and that's your resultant. So you would basically say cosine 60 is equal to x over 30 meters per second, right? Because cosine is adjacent over hypotenuse. Your hypotenuse is 30 meters per second, and your x is the variable that you want to find. So what we would do is cosine 60 times 30 meters per second, which equals, let me just calculate that out. 15 meters per second. So that equals your Vx. I usually use x as a subscript to tell myself that, oh, this is the velocity for the x direction. Okay? And we know that in projectile motion in AP Physics 1, our horizontal velocity is always constant. So it's always going to stay at 15 meters per second. However, its y direction velocity does change because we have gravity acting. So what we would do is, and also, if I haven't mentioned before, at the peak of the projectile's flight, its y velocity, Vy, is equal to 0. Because at that instant, the object is not going up or down. It's just like midair, but moving to the right, if you could think of it like that. Because if it was never 0, the object would never be like a projectile. It would just keep on going up or keep on going down. But it has to have a point where it turns from a velocity in a positive direction to a negative direction. So since we know Vy is equal to 0 meters per second, right, on the top, we could also use the same equation, Vfy is equal to V naught y plus at. And a is your acceleration. And we know that our acceleration is constant, and that's just equal to g, right, as we discussed before. So we just write plus gt. So we know our Vfy is 0 meters per second because at the top, right, as I said before, it's midair. Is at that very instant, it's at 0. So we could basically cross that out and we would say V naught y is equal to negative gt, right? And we could solve for V naught y by just doing a simple trig calculation. and that's sine 60 equals y over 30 meters per second, right? So we would just do sine 60 times 30 meters per second, and that Vy should give you 25.98. Let's just round it to 26. 26 meters per second. So it's initially being launched in the x direction at 15 meters per second and a y velocity of 26. Okay, so we know, let's just bring this over. So we get this equation, 26 meters per second is equal to negative gt, right? But our g is negative 9.81. So what happens when you have a negative and negative? It becomes positive. So you actually end up with 9.81 meters per second squared times time, because the negative and negative cancel out. So, and that is equal to 26 meters per second. You divide both sides by 9.81. Yeah, no problem, RT. And so 26 divided by 9.81 is around like 2.6 seconds. Okay. And we can also do a unit check, right? Meters per second divided by seconds is meters per second divided by meters per second squared is equal to seconds. So that gives us our time. But that time is just from this projectile when launched at here to here. It's just from here to here, right? However, that projectile does come back down. And so what we would do is we'd take that time and times it by 2. And what does that give us? That's like what? 5.2? 5.2 seconds. Okay, so if you were finding the range of a projectile, right? Let's say it was not launched at a cliff, it was launched at a surface, a horizontal level. That time would give you 5.2 seconds. And to find the range, you just take 5.2 times its horizontal velocity, which is 15 meters per second. And that would give you the range. But let's say you wanted to find the time it would take to reach this bottom, right? This bottom. So that becomes a little more confusing. So basically, when it goes up, it's 26 meters per second, right? And it reaches its apex, and the Vy is equal to 0 meters per second. When it comes back down, we know that that time is the same. So we could also say that when it comes back down, it would also be 26 meters per second, but in the negative direction. Negative 26 meters per second. And if you don't trust me, you can make another calculation with the kinematic equation. Just use Vf equals V naught plus At. Just use Vf as 0. No, I mean Vf as your variable you want to find, and V naught as 0, because you're assuming it starts from the apex, and then solve for time. It would be the same. So now you have negative 26 meters per second, right? And now you want to find the time it takes from here to here, the actual bottom. So one thing you would do is you could do delta y is equal to, actually, do I even have to do it? Actually, yeah, I should do. Wait. Actually, I can just do it simpler. Sorry, you don't even have to use this stuff. You can just use Vf equals V naught plus At, right? You just use your V naught as negative 26 meters per second, right? And your Vf is 0 because you're assuming that once it hits the ground, its velocity becomes 0 meters per second, right? It hits the ground. It's not gonna what get sucked into the middle of the planet, right? It's just going to stay there, and that velocity is going to be 0. So you get 0 equals this plus At. Wait, I'm sorry. You can't actually use this equation. I forgot about the distance. You could actually use, the reason why I don't want to use the third equation is because it's more complex. You would basically end up with a quadratic equation because like ax squared plus bx equals plus c. You would basically end up with that, and you would have to do like a factorial to find out your time. But I think you can use it using the second equation, vf squared equals v naught squared. So sometimes if your first equation doesn't work, you can just try the second. vf v naught is, what is it, 20? Negative 26. 0. So 26 squared is 676 equals 2, 9.81, and then delta x. And divide both sides by 2 times 9.81, and that would give you your delta y range. So basically, you would take that delta y. I'm sorry. I kind of messed up in the middle. I have to look back into this calculation. But basically, the first, second part are correct. It's just after this, finding the cliff height. I haven't done this for like a long time, so I do have to get back to my notes and tell you afterwards. But does this answer your question so far? Okay. Yeah, I'll definitely, if I can, I'll try to find an article or something that can help you. I've done this before. It's just, it's been so long that, like, because I was studying mostly on like rotational stuff, so I haven't done kinematics for such a long time. But I'll definitely get back on to you for this question. All right, are there any other questions? But doesn't equal number. Okay, so negative 9.81 meters per second squared is not the force of gravity. It's a measurement of how strong that gravity is pulling on you. It's like a gravitational field strength. It's not really a force. So the next unit I'll be talking about is dynamics, and that'll be talking about like forces, like Newton's laws, things like that. But yeah, it's not a force. It's how strong something's pulling on you. Okay, so Jake, do you have any questions? All right, so I'm just gonna stop recording.